Good afternoon, good morning, good evening. Welcome back to Chemistry A, Unit 3, Quantum Mechanics, Intro to Bonding. This is day 4, so let's begin. Okay, now, we're going to talk today about a different type of bonding. It's called covalent bonding. And unlike ionic bonding, where there is a tug of war for the electrons between the atoms that are bonding, covalent bonds will hold those atoms together by sharing electrons. This is what I call the kindergarten bond. They share the electrons, okay? The reason why this takes place is because you're talking about nonmetals bonding with other nonmetals. And as if you recall, nonmetals will always take or receive electrons. Well, if you have two nonmetals receiving electrons, you have two atoms in the bonding relationship who want to take. Somebody has to give. Well, they won't give. So what they do is they will share. Okay. Some elements that we find in nature form a neutral group of atoms joined together by covalently called a molecule. All right. Over here to the left-hand side, you see a picture of a hydrogen molecule, an oxygen molecule, a nitrogen molecule, and a chlorine molecule. Now, those are drawn bigger on purpose because hydrogen atoms bonded together are smaller than the chlorine molecule when the two chlorines are bonded together. Okay, we call what we see on the left-hand side of the screen diatomic molecules. That is because there are two atoms making up a molecule. There are other molecules like H2O, which are made out of three atoms, but when we have two atoms bonded together, we call it a diatomic molecule. All right. Molecular compounds are compounds composed of molecules. They will tend to have relatively lower melting points and boiling points. That is because the bond strength in a covalent bond is not as strong as an ionic bond. Okay. Now let's remember the octet rule in covalent bonding. Okay. Electrons sharing occurs so that atoms attain noble gas configurations. Hydrogen achieves noble gas configuration with 2 electrons, while group 4A through 7A, we're talking the periodic table, achieve noble gas configurations generally by acquiring 8 electrons, or what we call an octet. Okay. Now remember what we're talking about. Group 4A and through 7A, we're talking about those groups on the periodic table. Okay. An electron dot structure represents the shared pair of electrons by 2 dots. All right. The structural formula represents the covalent bonds by dashes and shows the arrangement of atoms. So in the first box on your note guide, would you please at this point draw the fluorine bond on page 218. You do not have to draw the 2 little circles for the fluorine bond if you don't want to. Okay? So as you can see in the fluorine bond, we have electron dots. That's called a Lewis dot structure, by the way. The electron dots will show you in the middle there of the fluorine. You will see one fluorine will contribute 1 electron, and the other fluorine will contribute its electron, and they will share a pair of electrons to create this bond between the two. All right. Now, if you notice around the outside of the electron, there are pairs of electrons that are not involved in the bonding process. They are not shared between those atoms. Okay. At this point, would you please draw the water molecule at the bottom of page 218? Again, you do not have to draw the circular model if you do not wish to. Okay, now every once in a while you will get something that is called a double and a triple bond. And what this states is that, look, 1 electron contributed from each atom is not going to be enough. there are times when atoms will bond by sharing more than one pair of electrons. This is called a double or a triple covalent bond. If there are two shared pairs, this is called a double covalent bond, as you will notice when you draw the oxygen bond on page 221 in the box below. As you can see in the oxygen diatomic molecule that you drew, each oxygen, will have to contribute more than one electron to the bonding process, because sharing just one each with the other is not going to make a stable octet. Remember, we're trying to get to 8 electrons in the outer shell. So as you can see, the oxygen will share 2 of its electrons, and will share with the other oxygen 2 of its electrons, and that will be called a double bond. The double bond is shown by 2 dashes, each dash representing the electrons, a shared pair. Now, we also have something called a triple bond. Okay, this is where there's 3 shared pairs. It's a triple covalent bond. All right, please at this time draw nitrogen at the bottom of page 221 in the box below. After you've drawn that nitrogen bond, you will have noticed that, look, 1 electron pair is not enough to satisfy the octet rule to make 8. Neither is 2. So we draw a third pair. A third electron is shared from each nitrogen, and that will mean nitrogen has 5 valence electrons. The other nitrogen will have 5 valence electrons. They will share 3 each, and that will be a triple bond shown by 3 dashes. So a single bond is shown by a single dash, a double bond is shown by 2 dashes, and a triple bond is shown by 3 dashes. Now, one note, in very large molecules, you can have some atoms bonded to another atom as a single bond, and then other atoms bonded within the same molecule to other atoms as double or triple bonds. So you can have multiple types of bonds within molecules. Okay? And also note that there is no such thing as a quad bond or 4 shared pairs.